Hello and welcome to another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 4, Lesson 1 on ordering positive numbers. Now, this unit is all about introducing you to what are known as negative numbers. Today though, we're just going to be working with your garden variety numbers that you've been working with all along, and we're now going to start calling them positive numbers, all right? And ordering them just means basically, hey, which number is greater than the other number? That's it, you know, putting them in order from least to greatest, kind of. All right, so let's jump in and let's review some really important ideas when it comes to ordering positive numbers. Here we go, plotting numbers on a number line, right? This is extremely important and you've been doing it for years and years. So let's take a look at exercise number 1. For each of the following numbers represented by a letter, plot the point on the number line as accurately as you can and label it with your letter. Or label it with its letter, you know, not maybe your letter. Anyway, here we go. And it's simple enough. Like for instance, we'll do letter A or point A or number A or whatever first and then have you do the rest of them on your own just to see how well you do. So A is 4.5, right? And that's simple enough. Here's the number 4, here's the number 5. 4.5, as we should feel comfortable with decimals, simply lies halfway between 4 and 5, right? It would be 4.1, 4.2, 4.3, etc., 4.5, 0.6, 0.7, etc. So 4.5 should lie right there, easy as they come, so I'm going to put a dot there and throw down letter A, right? Now, of course, what I want to do is I want to locate all the rest of them. These two might be a little bit challenging to think about, but if you have a problem thinking about them, maybe convert them into mixed numbers first, and then they should be easier to plot. Pause the video now and see if you can figure out where the remaining 4 numbers should be plotted. Now, notice it said plot the numbers on the number line as accurately as you can. And here's what I mean by that. Letter B is at 7 1/3, right? Well, we know 7 1/3 is between 7 and 8. We know 7 1/3 should be less than 7 1/2, which is sitting right there. So 7 1/3 should be plotted somewhere in here. Am I going to get it perfect? I guarantee I'm not, right? But I can say it's probably somewhere right around there. The same is true for 1.7, right? 1, 2, here's 1.5, so 1.7 has to be between 1.5 and 2.0. So maybe our letter C is right about there. Now the most challenging ones are these two, right? But probably to figure out where 21/8 should be plotted, it would be easiest to convert that into a mixed number. So 8 goes into 21 2 times, right, for 16. And then we have 5 left over, so 21/8 is 2 5/8. Now where should I plot 2 5/8? Well again, here's 2, here's 3, it's got to be somewhere in between them. 2 4/8, right? 4/8 is 1/2, so 2 4/8 would be right there. 2 5/8 would just be barely past the 2 1/2 mark. So maybe right about there. Now the final one should be very, very easy, 15/5. And the reason that that should be easy is that 15/5 is simply the number 3, right? Never forget that fractions and division are the same thing. This is the same as 15 divided by 5, and 15 divided by 5 is equal to 3, which means letter E is sitting right there, very close to letter D, very close. All right, simple enough, right? Plotting points on a number line. But it's extremely important to be able to plot points on a number line because we're going to use number lines to help us determine what numbers are greater or less than other numbers. Let's move on and take a look at more of this. Here we go. Now, one thing is certainly true, right, in that a number line, any point on a number line corresponds to a particular number, right? And every number has a location on a number line. But we can kind of zoom in on a number line so that, you know, we're getting more and more decimal places, if you will. Exercise 2 illustrates that. Let's take a look at it. The portion of the number line between 2.5 and 4.5 has been shown below. Plot each of the following on the number line and label them with their letters. Now, it's very, very important to always know what a number line goes by. All right? So in other words, here's 2.5, here's 3.0 and 3.5. This number line is going by, very understandably, it's going by tenths, right? Here's 2.5, then we'd have 2.6, 2.7, 2.8, 2.9, 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, etc. So when I see something like 3.6, that's pretty easy. I can plot it in its exact location right here. Right. So what I'd like you to do now is pause the video and plot the remaining 4. All right, let's go through them. Of course, there's no reason why we can't plot a whole number on a number line that's got decimals on it. So when b is equal to 4, that's pretty easy. It's right there, no problem. 4 and 4.0 are, of course, the same number. Now, 2.8, that's not going to be a problem either. Here's 2.5, so 2.6, 2.7, 2.8. 2.8 is going to be sitting right there, right? So there's my letter C, right? Letter D is at 3.4. There's 3, 0.1, 0.2, 0.3, 0.4. So we've got letter D right there. And finally, the hardest one to locate, but it shouldn't be too bad, is 4.35. Here's 4.1, 4.2, 4.3, right? Let me just write this down, like little arrow, right? Here's my 4.3. Here's my 4.4. And 4.35 would have to be halfway in between them, right? Now, follow-up question, exercise number 3. Let's try to keep that number line on there. Which two numbers in exercise 2 are closest to each other on the number line? How far apart are they? All right. Well, I'd like you to look at the number line, literally look at where those 5 letters have been plotted, and the first thing I want you to answer is the first question, which two are closest to each other? And then the second part of the question is, what's the distance that separates them? How far apart are they? Pause the video now and see if you can answer these questions. All right, well, it should be visually obvious that the two numbers that are closest together on this number line are A and D, right? They're very, very close together. So that just answers the first one, A and D. Now, how far apart are they? Like literally, what distance separates them? Well, you wouldn't want to say 2 or 2 units because that's not correct. In fact, right, from here to here is 0.1 unit, and from here to here is 0.1 unit. So they are 0.2 units apart. Another way to do that would actually be to take their values, 3.6 and 3.4, and simply subtract them, giving us 0.2. That will always tell us how far two numbers are apart from each other on a number line. But we'll look at that a little bit more in Math 7. Anyway, let's keep going. Let's zoom in even farther, right? We could keep blowing a number line up. It's like putting it underneath a microscope and making it bigger and bigger and bigger, right? So that you can get maybe more accurate and accurate and accurate numbers. So exercise number 3. You can zoom in on a number line in order to plot numbers with even greater decimal places. Plot numbers below on the number line shown. And again, it's important to understand here, right? We're going from the number 3 simply to the number 3.2. And we're doing it now in terms of hundredths, right? So here we've got 3.01, 3.02, 3.03, 3.04, 3.05, 06, 07, 08, 09, 3.10, but we don't label it as 3.10, we just label it as 3.1, and 3.11, 3.12, etc. So if I want 3.14, right, here's 3.1, 3.11, 3.12, 3.13, 3.14. Right? We're doing these things now accurate to the nearest hundredth. Why don't you quickly pause the video and plot B and C? All right, it's going to be easy. Here we go. Right, 3.02 is going to be right here, and 3.18 is going to be right there. All right, awesome. Now, we're going to segue at this point in the lesson to starting to talk about greater than, less than, or equals to. Let's look at that in the next exercise. Comparing numbers. Exercise number 4. For each of the following number pairs, place one of the symbols, greater than, less than, or equals, in the circle to make the statement true. All right. Right, so it's very simple. I'm comparing the number 18 to the number 12. Now, hopefully, we all are very comfortable with the fact that 18 is greater than 12. And keep in mind, these two symbols, right, this symbol and this symbol, they are technically different symbols, technically, but I don't really even think about them that way. What I think about them as is the number that's on sort of the open side of the symbol should be greater than the number on the pointy side. That means this is technically the greater than symbol and this is the less than symbol. So in other words, for here, I would say that 18 is greater than 12. All right, there's no question about that. All right. On the other hand, when I look at something like letter B and I'm comparing the number 8 to the number 32/4, well, I might need to do something with 32/4. I might need to reduce it. I might need to convert it into a mixed number. The plain fact is 32 divided by 4 is also equal to 8. And so here, there's an equality. You see, sometimes, right, especially when it comes to things that are written in fraction form, two numbers can look different, like 8 and 32/4, but they can actually be the same number. Now, let's do one more together and then kind of have you do some of them on your own. You know, we might even have to be comparing decimal quantities. And this should be pretty easy. We've got 1.97 versus the number 2. All right? And hopefully what you know is that 1.97, simply because there's a 1 there and there's a 2 there, 1.97 is going to be less than 2. Right? We're just really kind of having to compare those two numbers. Okay? So what I'd like you to do now, and some of these get a little bit tricky, especially down here where we've got some fractions and things like that involved, is I'd like you to think about each one of these scenarios, put either a greater than, an equals, or a less than symbol in to make the statement true. Pause the video now and take some time to do this. All right, well, let's talk about letter D. 5.2 versus 5.200. This one's extremely important. You've got to look at these two numbers and you've got to know those are equal, right? I can tack on 0 after 0 after 0 after the decimal place and it makes no difference because I'm literally adding on no additional hundredths, thousandths, 10,000ths, etc. So these two are identical numbers. All right? They may not look identical, but they certainly are identical. Now let's take a look at these, right? So again, 4.0946, 4.113. The key with comparing kind of numbers written in decimal form is to sort of compare them digit by digit. So 4 and 4, right? Those are equal. No big deal, okay? But then when we move to the next digit, 0 and 1, it doesn't matter what any of the other digits are. At this point, it's like comparing the number 40 to the number 41, all right? It doesn't matter what comes after it, totally irrelevant. The plain fact is this number is now less than that number. All right, now something like this, 9 halves and 19 thirds, for me at least, the easiest way to compare these two is to convert them into mixed numbers. All right, so for instance, 9 halves is the same as 4 and 1/2. 19 thirds is the same as 6 and 1/3. All right, now again, it's kind of like the last problem. It really doesn't matter what these two fractions are that are tacked on. The plain fact is 4 is smaller than 6. So 9 halves is less than 19 thirds. All right, and we can do the same thing with this problem. All right, 11 halves, right? We could rewrite that as 5 and 1/2. All right, 33 thirds, we can write that as 5. Whoops, come on. There it is, 5 and 3/6. Now, this one could be a little tricky though, right? Because, well, 5 and 5, that's the same, all right? Then we have 1/2 and 3/6. 3/6 is the same as 1/2. All right, this really is just 5 and 1/2 again, so those numbers are equal. Now maybe the trickiest one of all, 0.3 repeated and 0.32 repeated. For this, it may make sense to write out some of these repeated decimals. So the number on the left is this, and the number on the right is this, forever. So we're back to this kind of deal where we're comparing them digit by digit, right? So we've got a 3 and a 3, okay, that's fine. Then we've got a 3 and a 2, and that's all you need. That means that number is greater than that number, right? We just kind of go down the line. Ah, those are equal, that one's bigger than that one, so we're done, okay? It's very, very important for you to be able to say with positive numbers, the numbers that you've been dealing with, which one's greater, which one's less, and maybe if they're equal. Let's do a little more work on this. One more problem. All right. This is extremely important for what we're going to be doing in the next lesson and lessons after that. An important geometric fact about comparing numbers. Exercise number 5. Plot the following 4 numbers on the number line shown below and label them with their letters. Then fill in the number comparisons with greater than, less than, or equal. All right, simple enough. So let's do this. Let's have you pause the video, fill this out again, just plot those 4 numbers, then compare in these blanks, and then we'll talk about them. Take a few minutes. All right, here we go. Well, a equals 5. You don't get any easier than that. That's going to be right here. B equals 4.2. Also pretty simple. C equals 5.7. Not bad. Maybe the only one that's challenging is 20/4, but 20/4 is also 5. So it's a little bit tricky, but I'm going to put a little arrow here and put a D there as well. All right? Now, when we actually do the comparison, 5 and 5.7, well, 5 is less than 5.7. Let me just move this up here. 5.7 is greater than 4.2, and 5 is equal to 20/4. Now, you might say, well, what geometric fact am I really trying to figure out here? Well, let's talk about that in exercise 6. It says fill in the blanks below, but I'd like to do this one together, right? Letter A says a greater number will always be plotted to the blank of a lesser number. All right, so let's take a look at this, right? 5.7 is greater than 5, right? So where is 5.7 compared to 5? Well, there's 5.7 and there's 5. And 5.7 is plotted to the right of 5. Likewise, 5.7 is greater than 4.2. There's 5.7. There's 4.2. And again, 5.7 is to the right of 4.2. And that is always the case. So in other words, a greater number will always be plotted to the right of a lesser number. Likewise, letter B, a number plotted to the left of another number is the lesser of the two. So if I'm comparing 2 numbers and one of them lies to the left of the other one, well, then that one is the lesser or the least of the 2 numbers. And finally, maybe the easiest thing ever, 2 numbers that are plotted in the same place on the number line are equal. It's actually a fantastic way to think about equality in terms of geometry, right? If I've got 2 numbers that are in the same place on the number line, then they're the same number. It kind of makes sense, all right? But really, this is absolutely key, all right? And it's going to be important once we start to look at the somewhat confusing topic of negative numbers and how we kind of compare negatives to other negatives or negatives to positives or things like that. All right, let's wrap this thing up. So today, we did, hopefully, some easy work. Plotting some numbers on number lines. Maybe that got a little tricky if the numbers were fractional or if they had decimals in them, right? And then we compared numbers, whether one number was greater than, less than, or equal to another number. Both of these are going to be absolutely critical skills to have as we move forward in this unit and as you move forward in math in general. For now, I'd just like to thank you for joining me for another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.